Today we're going to talk about solving systems of linear equations by graphing. Systems of linear equations is basically when we have more than one equation and we're trying to find common points that would be in both equations. There's several different methods that we're going to talk about this year, but the first one we're going to look at is how to determine the solutions by graphing. So a system of linear equations is a set of two or more equations. A solution of a system of linear equations is the ordered pair, the x and y coordinates, that is a solution of each equation in the system. So to be a solution of the system, you have to be a solution to both or more equations, however many equations are in that system. You can see the solution in the graphing method because in the graphing method, the solution is the intersection point. A system of linear equations is also called a linear system at times, but basically what we're going to try to do is use our graphing method to be able to find where do these two equations intersect, which means they're sharing that point. So when you remember how we graphed lines, basically what we are looking for is y equals mx plus b, where m is your slope and b is the first point that we start with, our y-intercept. We use our y-intercept and then the slope from that point to find the next point to then be able to show our graph. So the other thing about these systems is we're going to graph the two equations on the same coordinate plane because basically these two are a system together, so they go on the same graph. So let's look at this first example. So we already have the x and y's drawn in. We have these two equations, y equals 2x plus 5. So what that is basically telling us is the following. So 2x plus 5. 1, 2, 3, 4, 0, 5 is my y-intercept. That's the b value right there. The 2 is telling me my slope is 2. So I'm going to go up 2 over 1. That will be my next point. And again, I can go up 2 over 1 to find another point. And from here, we're going to draw a nice straight line. Hopefully this is nice and straight. Down there. And just to label our graph, y equals 2x plus 5. So then on the second graph, we have negative 4x minus 1. So remember, minus 1 is where we start then. 0, negative 1 is my y-intercept. Now a negative 4 slope. And we said we can use that in a couple of ways. I can go up 4, 1, 2, 3, 4, but then backwards 1. I could also come down 4 and forwards 1. And that would allow me my 3 points to be able to draw this equation. Y equals negative 4x minus 1. So what we're looking for is this point right here. This point is our intersection point. And it appears to be negative 1, 3. But how do I know that that's the right answer? It looks like it's the right answer. It should be the right answer. I have to check it. The way I know this is the right answer is I should be able to take both equations separately and plug in negative 1, 3. So in the first one, that's going to be 3 equals 2 times negative 1 plus 5. Now I have all numbers, so I would just use my regular PEMDAS. And basically I'm looking for is negative 2 plus 5, 3. It is, so it works. But to be a system, it has to work for both. So then I have to move over to the second one, plug in the y as a 3, Negative 4 times negative 1 minus 1. Negative 4 times negative 1 is positive 4, and 4 minus 3 is 3. So it works for that one. And at this point, this is where I can say my answer or my solution to this system is negative 1, 3. So next we want to talk about another type of system, which is now the word problem. Writing systems is certainly not an easy thing to do. Basically what we are doing is we're trying to take a whole bunch of information, too much information for one equation, and write two different related equations that are talking about the same subject. Once we have the different equations, then we can put them as a system and figure out where they share the same points. So here's what's going to happen on this one. I want to read through the information and see what I have. So right away, kicker on a football team scores 1 point for an extra kick. Okay, 1 point for the extra point or the extra kick. 3 points for a field goal. That one is obviously talking about the number of points you get for those different types. A kicker makes a total of 8 extra kicks and field goals. The kicker scores a total of 12 points. Write and solve a system of linear equations to find the number of extra points and the number of field goals. They're also defining for us that the extra kicks are x's and the y's are our field goals. So x's and y's, we've defined our variables. So really there's too much information to kind of cram into one. So I'm going to focus on two different ones, and these little number boxes have already kind of helped us lead it out. So way back in the very first sentence, we're told how many points we get for each one. So if you look at the second sentence, it talks about a total of 8 kicks. Okay? That would be looking at the extra point kicks plus the field goal kicks, and we know that we made 8 kicks. So this one is referring to kicks. The second one is then looking at the points that this kicker got based on the kicks. Well, what we know is that I get 1 point for each extra point. I get 3 points for each field goal, and that we had a total of 12 points. So what I want to think about here is when I look at the second equation, 1 point per kick times the number of kicks would tell us how many points we got. 3 points per kick times the number of extra points would tell us how many points we got. And that's where that plus 12 comes in. So to now graph these two, okay? If I'm going to graph these two, we have been making these turn into slope-intercept form. So all I need to do is look at my first equation. And remember, changing into slope-intercept form means solve for y. So I would subtract x. Which initially looks like that, but remember we said we need the mx in the front. So I move the mx. The sign in front stays with it. It's negative x plus 8. The second equation is going to be x plus 3y equals 12. Again, we're solving for y. So I would first move the negative x to move it on the other side. I'm just going to rearrange this correctly right from the beginning to get negative x plus 12. But then I have to do one more step on this one to divide by 3. So remember, that's going to give me y equals, and remember, this 3 has to go into both of these terms. So I'm going to get negative x divided by 3. And then I'm also going to do 12 divided by 3 to get 4. So now I'm going to graph. Over here on my graph, what I want to think about here is just plotting my points, and we'll start with the first one. We have 8 is our y-intercept, and then we're coming down 1, forward 1, down 1, forward 1, down 1, forward 1, all the way down to the 8 on the other side. Now what I want you to notice here is, this is your x plus y equals 8 equation. What I want you to notice here too is we're not doing quadrants 2, 3, and 4. Obviously the reason for that would be I can't take negative kicks, so I wouldn't have negative field goals or negative extra points. So we're just making it in the first quadrant. So that's my first graph. My second graph starts at plus 4. Remember that negative x over 3 means negative 1x over 3. So my slope is actually come down 1 and forward 3. Down 1, forward 3. Down 1, forward 3. So if I was to connect those dots, I'm going to get something that's going to look like that. That one is the x plus 3y equals 12. So it appears that we are having an intersection point right there. So with that in mind, we're going to take that information off. So our x's, we said, were the extra points. And remember the y's are the field goals. So to answer my question, this point that we are saying is the intersection point is 6, 2. So 6 extra points, 2 field goals. And that's how we solve a system with graphing.